Hello grade 5 learners. Today in this lecture we are going to talk about fractions. We already learned what's the meaning of a fraction and what does it express, but today we are going to learn about fractions more. We are going first to define what's the meaning of equivalent fractions and how do I make equivalent fractions, and then we are going to compare like and unlike fractions. So let us first of all start by defining what's the meaning of equivalent fractions. Equivalent fractions, from the word equivalent, you can say that something which is equal. But we cannot say fractions are equal because they are not numbers. They are not only numbers. We say that fractions are equivalents when they express the same amount or the same quantity. Okay, when two fractions they express the same amount, then we say that those two fractions are equivalent. We don't say equal because actually you're not going to have the same numerator and the same denominator, as you can see in this example. So in the first drawing we have 2 over 4, while in the second one we have 4 over 8. We don't have the same numbers, but they actually express the same amount. If you look at the first circle, we divided the circle into 4 parts and we colored 2 out of them. While in the second circle, we divided it into 8 parts and we colored only 4 parts out of 8. If you can see, for the circle, we colored the same amount in both of them. So we can say that those two fractions are equivalent. Why they are equivalent? Because they express the same colored amount, but they are not equal numbers. So what do I mean when I say equivalent fractions? They are fractions that express the same amount. Let us take another example. So as I said, the equivalent fractions, they have different value. When I say different value, I mean different numerators and denominators, but these fractions, they express the same amount. This is a pizza. Suppose you have a pizza and you divide it into 2 parts and you ate 1 part out of 2. While if you divided it into 4 parts and you ate 2 parts out of 4, that's the same amount. So 1 over 2 and 2 over 4 are equivalent fractions. Even if we divide the pizza into 8 pieces and we ate 4 out of 8, that means I ate actually half the pizza. So it expresses the same amount. Now, how can I make equivalent? So if I have a fraction and I need to find its equivalent fraction, what do? Actually, there are 2 ways. The first one is by multiplication, and the second one is by division or simplification. Now we're going to start by the first way, which is the multiplication. So to make an equivalent fraction, we multiply the numerator and the denominator by the same number. Then you will get a new fraction with the same amount as the original fraction. Actually, we are not changing the amount of the fraction because we are simply multiplying by a fraction that's equivalent to 1. What I'm trying to say is, when I have here 3 over 5, when I multiply by 4 over 4, the numerator and the denominator, I'm multiplying by this fraction by 1, because you know that 4 over 4 is equal to 1. So you know when you multiply anything by 1, it never changes. So let us go to the main idea, which is I need to multiply the numerator and the denominator by the same number. So now I chose 4. Of course, you can choose any value you want, any number you want, but you should make sure that you multiply the numerator and the denominator by the same number. So if you multiply 3 times 4, it's 12. Now 5 times 4, it's 20. Let us check if those two fractions actually represent the same amount. We bring a square or a rectangle and we divide it into 5 equal parts, and we colored 3 out of them. Now in the second rectangle, we divided it into 20 equal parts and we colored 12 out of 20. So if you can see here, I colored actually the same amount. I colored the same amount. Can you see it? Okay, so now I just prove it that 3 over 5 is equivalent to 12 over 20. We say those two fractions are equivalent. We don't say they are equal because 3 is not equal to 12 and 5 is not equal to 20. But we say that those two fractions are equivalent fractions, so they represent the same amount. Here's another example. We have 2 over 3 and we multiply this fraction by 3. So the numerator by 3 and the denominator by 3. So we got 6 over 9. So equivalent fractions. So we say 2 over 3 and 6 over 9 are equivalent fractions. So you can multiply the fraction by any number you choose, okay? But sometimes we would give you those two fractions and we are going to tell you that those two fractions are equivalent. So you look and check. How did the 3 became 9? We multiply the 3 by 3. So here you should multiply the 2 also by 3. So what do you get? You get 6. Okay, so we multiply the numerator and the denominator by 6. Sorry, by 3 to get 6. Okay, so let us take another example. Here we have 4 over 9. It's equal to something over 36. You ask yourself, those two fractions are equivalent. So what did we multiply the 9 by? We multiply the 9 by 4. So I need to multiply 4 by 4, so I got 16. So we say that 4 over 9 is equivalent to 16 over 36. So now we are just trying to guess the missing number. So here, how did the 8 became 72? We multiply the 8 by 9. So if you multiply the 5 by 9, you are going to get 45. So we can say that those two fractions are equivalent. Another way to find equivalent fractions is to divide the numerator and the denominator by the same number. It's like the multiplication, but you have to divide by a number which you can't divide the numerator and the denominator by. So suppose, for example, you want to divide this fraction by 2. It's not going to work out because 35, it's not divisible by 2. So you have to pick a number to be able to divide the 28 and the 35 by. So if you think well, of course, it's 7, because 28 is divisible by 7 and 35 is divisible by 7. So I'm going to divide both terms by 7. So I will get 4 over 5. So in this case, we say that 28 and 35, 28 over 35, it's equivalent to 4 over 5. Now, in order to write a fraction in its simplest form, when I say simplest form, means I can't divide it anymore. So you know that sometimes a fraction, you might divide it by many numbers, so you should divide it in several steps, or you can divide it one time by finding the greatest common factor of the numerator and the denominator, and then divide both numbers by this greatest common factor. So look at 20 and 28. You know that 20 you can divide it by 2. Also 28 you can divide it by 2. But I will try to guess the greatest common factor for both of them to divide it only one time. So instead of dividing the first time by 2, then the second time by 2, or by 3, whatever the number is, I will try to find the greatest common factor. How? By listing the divisors of 20. Do you still remember our first lesson when we learned how to find the divisors of a certain number? So 20, the divisors of 20 are 1 and 20, 2 and 10, 4 and 5. Also 28, it's 1 times 28, 2 times 14, and 4 times 7. I'm going to arrange them as we used to do in the first lesson. So we list the divisors of 20 and the divisors of 28, but the greatest common factor is 4. So the common factors are 1, 2, and 4, but the greatest one is 4, so I'm going to divide both terms directly by 4. So I will get the fraction which is in the simplest form. It's 5 over 7. So 5 over 7, we say that this is the simplest form of the fraction. Now we will start by our last objective, which is comparing fractions. I think you already learned this before in grade 4, but I'm going to remind you of the comparing fractions. So when denominators of the two fractions are the same, we call them like fractions. And here we have 4 over 6 and 5 over 6. Where do I colored more? Of course, I colored 5 over 6. So when the fractions have the same denominators, the greater the numerator, the greater the fraction. So 4 over 6 is less than 5 over 6 because the numerator here is greater than the numerator of the first fraction. So that's when I have denominators the same. What if I have numerators the same? So if I have 3 over 4 and 3 over 6, actually, when I have the numerators the same, the less the denominator, the greater or the larger the fraction. Okay? So when the numerators are the same, it's opposite with that of the denominators the same. Okay? Now what if I don't have the numerators or the denominators the same? What should I do in this case? Okay, what I'm trying to tell you now is that I need to make those two fractions the same. If you look at them, what do I have? I have 3 over 8 and 5 over 12. I don't have the same numerator or the same denominator. The steps are very easy. You need just to make the denominators the same. Look at 8 and 12. You need to search for a number which is common for 8 and 12. Common multiple, of course, but the least one to make things easier for me. The least common multiple of 8 and 12 is 24. Why? Because 8 times 3 is 24 and 12 times 2 is 24. So I multiply 8 by 3. That means I have to multiply also the numerator. I can't only multiply the denominator. So I got 9 over 24. In 5 over 12, I'm going to multiply the 12 by 2, so I get 24. Also the 5 by 2, so I get 10 over 24. Now I can compare them because I got the same denominator. So both of them, they have the same denominator. So the bigger the numerator, the bigger the fraction. So 10 over 24 is greater than 9 over 24. Now I'm going to do this exercise to make things clear for you. So we have here two fractions and we need to compare them. If you look at the first one, what do we have? We have 4 over 6 and 12 over 12. I'm just trying to solve these to help you make them very fast. So you know that 12 over 12 is equal to 1, right? And 4 over 6, we already learned from the previous lesson that it's less than 1. It's a fraction less than 1. So directly I can say that 1 is greater without even trying to make the fractions have the same denominator. The second one is very easy. They are equal fractions because they have the same values. 10 over 10, you know that it's equal to 1, and 6 over 6, it's also equal to 1. So you know that those two fractions are equal. Also here we have 12 over 12, which is 1, but 10 over 11, it's a fraction which is less than 1, so directly this fraction is greater. 7 over 7 is equal to 1, 8 over 8 is equal to 1, so they are equal fraction. Okay, here we have 7 over 11 and 9 over 11. You know, when I have two fractions of the same denominator, the bigger the numerator, the bigger the fraction. Now what do I have? 11 over 12 and 10 over 12. They have the same denominator, so the bigger the numerator, the bigger the fraction. 3 over 3 is equal to 1, while 3 over 6, it's a fraction less than 1, so directly 1 is greater. 5 over 6 and 8 over 8. 8 is equal to 1. 8 over 8 is equal to 1. So 1 is greater than 5 over 6. Here we have 1 over 11 and 1 over 6. Two fractions. They have the same numerator. So the smaller the denominator, the bigger the fraction. While in this one, we have the same denominator, but different numerators. So the bigger the numerator, the bigger the fraction. Here we have 1 over 2 and 8 over 11. They don't have the same denominator, and they don't have the same numerator, and none of these fractions is equal to 1. So what should I do? I should multiply the fraction. So here I'm going to multiply by 11. And here I'm going to multiply by 2. Why did I choose this? Because you know that 22, it's the common multiple of 2 and 11. So here I will get 11 over 22. And here I have 16 over 22. So now I can compare them. Okay, so you know that 16 over 22, it's greater than 11 over 22. Now here, number 5, we have 2 over 2 is equal to 1, so directly 1 is greater than 2 over 9. 1 over 12 and 2 over 12, you know that 2 over 12 is greater because the bigger the numerator, the bigger the fraction. 6 over 6 is equal to 1, so 1 is greater than 6 over 7. Here we have 2 over 9 and 1 over 2. I don't have the same numerator or the same denominator, so what should I do? I should make the denominators the same. So I need to multiply the 9 by 2, so 2 by 2, and here I should multiply by 9. How did I know? Because the common denominator for both of them is 18. So both of them, they will have 18 as a denominator, so 4 over 18. And here I will get 9 over 18. So which one is greater? 9 over 18 is greater than 4 over 18. So that's just to help you how do you do those fractions, how do you compare them. I advise you to work on the others. Of course, we are going to do them in the live session, so practice them to make things clear for you, okay?